Okay. And just as a heads up, I'm not going to get rid of my little control screen. I know it's huge and it's in the way, this thing, but I can't see when you guys are chatting and asking for help or making comments that way. So I'm going to keep it up and just move it out of the way. So please bear with me. All right. So this lesson in Edmentum is called Functional Values. Functional values. But basically, what I want you to think of today and this whole lesson as what happens to the individual coordinates when we do the transformations that we were doing last week. Before we get started, I want to have you do a quick warm up, okay? A little algebra warm up because we're going to be doing this kind of algebra for today's lesson. So I'm going to put up four different small math problems, and I want you to practice at home for each four of them. Here we go. Simplify each of the following expressions. Start with these four math problems. Do your best. I'm not going to call on you and make you answer, but I would like to hear your guys' answers if you would feel ready to share today. So take a few moments and do all four of these.
Good morning, teacher.
Good morning, Victor. Victor, Beniam, and anyone else who just joined, please start by trying these four problems on your own. Don't put your answers out there yet. We'll do them together one at a time, but I want you guys to try it on your own first. This is just a practice and a warm up because we're going to
All right.
be doing this kind of stuff in today's work.
Thank you.
Awesome. Okay. Okay. Let's go ahead and go over these together. If you feel ready to share with the group, let's type in your answers to number one, just number one, into the chat. All right, I see one comment so far. Did anyone else do number one? There's two comments. Awesome. It's just 1 plus 5. Start with that guy, and then we'll look at number 2 and 3 and 4. I appreciate you folks who have answered. That's great. Brooke and Savannah, awesome. And Anaya, totally. And who else? Someone else just did. Tatiana, awesome. 1 plus 5, 6. Thank you, folks, for trying that one out. All right, a little trickier. Number 2, 3 minus 5. 3 combined with a negative 5. Because it's minus 5, think of it as negative 5. And if you smash together positive 3 and negative 5, what's left? I know negatives are tricky, but that's why I wanted to warm up with it today with you so we get a little more practice. I appreciate you folks who are answering. There's 4 comments so far. I'm going to wait just a sec for those last people who want to answer. Brooke and Tatiana and Savannah and Anaya, thank you I appreciate you guys. So yes, a lot of you are saying negative 2. Let's see how we can work with combining negatives and positives like this. Notice the 3 is positive. Well, how do we know it's positive? There's no minus sign for it, right? Or negative sign. The 5, think of this as negative because it has that minus sign. So there's many different ways to add and subtract negatives and deal with negatives. There's many different ways. I don't have time to do all of them with you right now today, but we all have seen number lines. So we could start at 3 and then go backward because it's negative, or left 5. And that will take you down to -3 on the number line. And here's my favorite way. So forgive me because I know you folks have seen this before, but 3 positive. There's my 3 positive, and here's my 5 negatives. And think of them as like rushing towards each other in a big epic battle. And every plus takes out a minus, or vice versa. Okay. 1 plus, 1 minus cancels each other. So if we cancel out every plus with each minus that we can, we'll run out eventually. And what's left after this epic battle? 2 minuses, or -2. Okay. So when we're dealing with small enough numbers, we can use this like battle approach. Here's another quick way to think about it that'll get you the same answer. What is the space between 3 and 5? Forget about the negative for a second. Just ask yourself, what is the space between 3 and 5? 2. Now, which one of those numbers, 3 and 5, is bigger? Well, 5's bigger. And what sign was 5? It was negative. So that means the 2 that we're left over with, the space between 3 and 5 for our answer, will be negative because there's more of the negatives to start with. There was 5 of the negatives, 3 of the positives. So you can do your subtraction problems like that when we end up with like a bigger number that's negative too. You can just think, what's the space between them? And then if the bigger one is negative, that answer is going to be negative because there's leftover negative, not leftover positive. Or if the bigger one was positive, the answer would be positive. Okay, did anyone try number 3 and would be willing to share what they got? I see 1 in the chat. Anyone else? Anaya, high five to you, dude. Thank you for sharing. Let's work through it real quick together. So, quick tip on multiplying whole numbers and fractions. You can multiply the whole number to the numerator on top. Multiply the top numbers, basically, the whole number, if you have one, to the numerator, that's the top number. Numerator. So if we do that here, what do we get? 4 times 3 is 12, right? Still over 2. We haven't dealt with the dividing by 2 yet. Now we can try dividing it or reduce the fraction. So 12 does divide by 2, and it gives us a nice clean 6. So we can multiply those two top numbers. So 4 times 3 over 2, and that gives us a 12 over 2, and that boiled down to 6. If you do the same thing for number 4, what do you get? I'm going to give you guys a chance. Try that out. Multiply the 10 times 7 and then divide by 5. Three of you have answered. Anyone else? Let's go. There should be 11 of you. 10 times 7, then divide by 5. Awesome. Here's more coming in. 6 of you. Anyone else? Get that participation, folks. Let's go. At least try it. You don't have to get it right. Just try it. That's all I want to see. 7 of you. High five. I'm going to call it. Let's see what you guys got. Tira, thank you. And Tatiana. And Savannah, Anaya. Savannah, high five, dude. Anaya. Okay. Thanks, you guys. So if we multiply those two top numbers, we get 70, right? 70. Then try dividing by 5. That's a big one. I don't have that memorized. How do I figure it out? I use a calculator. 14. Now, what's another way to think about this? You could do this for number 3 as well. So we multiply the 10 to the numerator. Cool. But before multiplying, can I simplify just 10 over 5? Notice how we've got 2 numbers on top. We've got 1 number in the bottom of this fraction. And if you just kind of focus in on the top number that is divisible by 5, 10 divided by 5, doesn't that come out to a clean answer? 10 divided by 5? It's 2. So just 10 over 5 turns into a 2, and that's still being multiplied to 7, right? 2 times 7, 14. So what I did in the second version of it is simplify before doing the multiplying. We could do this over for number 3 as well. Look back. We've got 4 times 3 over 2. And last time we multiplied 3 times 4, right? But instead, let's simplify 4 over 2 first. 4 divided by 2 is 2. And there's still the times 3 hanging out. 2 times 3 is 6, same as what we got before. So feel free to try doing that, reducing your fraction before multiplying all the top numbers. It can make it a little faster, a little easier, and smaller numbers to work with. Okay, I wanted you to get ready for multiplying fractions because we're going to see some of those today. So now let's step back to what we were doing last week. So think back to the mastery test and all the work we did last week with translations and transformations. You guys were doing terrific, dynamite last week with those rules for how we shift it left and right and how we shift it up and down. So I need your mind to go back to that with me. Okay. My question for today, though, is what happens to the individual coordinates, meaning all the points that make up the function. So let's start by looking, like we did a lot last week, at this guy. F of x is equal to x squared. So that is the parabola shape. And just x squared, just x squared starts here at 0, 0. You remember. And then it goes up to 1, 1, and 2, 4. And how do I know these? All I'm doing is plugging in inputs for x and squaring it. So 1 squared is 1 over 2. 2 squared is 4. 3 squared is 9, right? 3 times 3 is 9. And then the next one would have us off the page. So I'm going to stop there. And then the left side looks just like the right side. So I would be at negative 1, 1, negative 2, 4, and negative 3, 9. And they disappear every time I put them up. Here we go. So there's my parent function. Sweet. Now, what happens if we translate f of x plus 2? Okay, before I do this, look at the rule here. The plus 2, it's in the parentheses. So what does that tell us? Can you tell me anything from last week? Meaning, if we're given this translation, is that a left, right, up or down? And then specifically, how many units left, right, up or down? Any ideas? It's in the parentheses. So that is telling us everything we need to know. I see a couple comments. I love you guys when you try like this. This is terrific. Let's see what you're saying. Anaya, thank you, Anaya. Antira, awesome. Yeah, it's horizontal, Savannah. And Anaya pointed out opposite when it's in the parentheses. So all three of you, high fives. Thank you so much. So we're going to go 2 units to the left or right. Is it left or right, though? it's going to be left towards negative. Why? Because we do opposite when it's in the parentheses. So we're going left or negative 2 because it's opposite in the parentheses. I know you're tired of hearing me say that, but it's not going to go away. So we have to remember opposite when it's in the parentheses. High five, you guys, when in the parentheses. And also, I got Tira. Good. Tira, thank you. Going left too. So let's put our translation up there real quick. I'm going to do it in purple, okay? So imagine all the points on my red function, my parent graph, going left too. So for instance, starting down here with the origin, the 0, 0, that goes over 1, over 2. Okay, this one next, 1, 1, that goes over 2. So here's the new 1, comma 1. And then how about this spot, 2, comma 4, originally, but we take it left 2, so it's over here now. I'm just shifting everything left 2. And then this one was originally at 3, 9. But now it's going 2 to the left, so over 1, over 2, right here. Now let's connect those guys. Yippee! Okay, and then to make it faster, I'm going to throw in the other side. Should be here and should be here, I think. Connect those. Okay, now this is just like last week's work so far. We were given the translation, we were given the original, the parent, and we shifted it over 2. What I want you to focus on is those individual points. So back in my writing here on the left, examine the parent graph and the coordinate 2, comma 4. So where's its new version after translating? It's here on our graph. What is that coordinate? 0, comma 4. So on the parent graph, we had a single point of interest, 2, comma 4. We translated using the rule f of what? X plus 2. And then what's the resulting new point or coordinate? 0, 4 on the translation. Sorry, that's so small. Translation. Compare those 2 points. What is the same about 2, 4 and 0, 4, and what's different? Anyone willing to share your thoughts? I know you see it. Can you describe it? What is the same between these 2 points and what's different? I know you see something that's the same there. What didn't change, right? The y part didn't change. Let's see what's in the chat. Very good, Tira. Thank you for noticing that. Yeah, it has the same 4. The 4s are the same, and that's the y, right? The y portion. And notice that the x portion went down too. X. Yeah, Levi.
I was going to say all it did was shift over to the left.
Yes, it shifted left, and we started with a 2, right? And then we compare that how it ended to a 0. So you could think of it as the x number minus 2. X went down 2. Levi, thank you. Good observation. Shifting to the left by the right amount from our translation, right? From the rule we were given, which was, in this case, f of x plus 2. Your mind now knows, okay, it's in the parentheses, so that's opposite of what it looks like, and it applies to the x, not to the y. The y stayed the same. X's had to go down 2, though, because the rule was plus 2. But then you know it's in the parentheses, so we do opposite, not face value. Before I look at another version like this, any comments, any questions, please? Don't hesitate to ask or throw in your comment. Yeah, go ahead.
I don't have a question, but you realize that, or you can tell that it stays in the same shape. The shape remains the same. It doesn't really change at all.
Beautiful. I'm so glad you noticed this. My drawings are a little funky, right? But we know that the shape is staying the same and it's just shifting over. And that's where the X went down by 2 kind of comes into play. And that's happening to all the points. Like if we did it with 3, 9, let's look up here, guys. And then where's the new version of 3, 9 in purple? It's right here. What is that? That is, I know my drawing is getting busy here. It's 1, 9. If we look at our units and figure that out, it's 1, 9. Well, same and different. The 9 stayed the same, shifting over. The x's went down by 2. 3 to 1, that's -2. And by the way, Levi, I like how you said that. There's an old Led Zeppelin song. I don't know if any of you listen to Led Zeppelin. Probably not. But it's called The Song Remains the Same. So now I'm thinking about that.
I know that song.
Awesome. Good for you. You guys should be listening to classic music of all stripes. Let's listen. Let's do another one. Okay. For this, I wanted to look at the same function, and we'll just focus on that same point, 2, 4. But here I have a different translation, f of x plus 2 on the outside. So real quick, I'm going to throw in our parent graph in purple. Okay, and there we go. And now we're going to do a vertical translation. How do we know it's vertical? Look at that translation rule. It's outside. You know what? Did I write the wrong thing on the last? I didn't. Okay. I'm going crazy. I'm losing it. So it's outside the parentheses, and that means do it vertically, and it means do it at face value, no opposites. So it's actually +2, but it's not going to apply to everything. It's only going to apply to the y's. So if we do that translation, I'll do it in red to compare. Think of all your original spots going up 2. So 0, 0 goes up 2, boom, boom, right here. 1, 1 goes up 2, 1, 1, 1, 2. And I'm going to do that for all of them. And I can't do it for the 3 because I guess I can. It's right here. Okay, so let's draw those. Okay. And then if I make it equal on the other side, the left side, up 2 for all those original guys. Boom, boom, boom. Okay, now if we focus on one point, let's look at 2, 4 again. So originally 2, 4 was on our parent graph. Our new version right here, what is that? 2, 6. Same question. What's the same? What's different? Here, x stayed the same, right? It was 2, 4, and it ended at 2, 2. So x wasn't really affected or changed, but y went up 2. And that's, if you look at any of the points, that's what's happening. The x didn't really change, but the y went up by 2. So the translation rule that we've been using all last week can tell us exactly what to do with any given point. So the game for today is to still use our rules from last week. So in the parentheses, it's horizontal, do the opposite. Outside the parentheses, it's vertical, do it at face value. And we're going to apply those rules and that logic to individual points. No pictures. We don't have to make a whole picture. All you've got to do is focus on the individual coordinate. Let's look at another example straight out of Edmentum. I just typed it, but this is an Edmentum problem, okay? So they're all going to be just like this. So assume 0, 7 is on the graph of f of x. That means 0, 7 is on our parent graph, on the original. Find the corresponding point for the function f of x plus 2. Now, look at that translation rule, the f of x plus 2. It's in parentheses. So that means horizontal, And we can tell it's specifically going to be left horizontal because it's plus 2. So we're doing opposites for inside the parentheses. Opposites. So we're going to take the whole original function and go left 2 units. Negative 2. Now for our 0.07, think about it this way. You're starting here. We do our translation, which we just figured out was going to be left 2 units, negative 2 to just x. Why just x? Because we're only dealing with horizontals. Y's stay the same. So what's our resulting corresponding point? Well, we know the y stays, so it's still a 7 for y. What's 0 minus 2? Give that a shot. Anyone willing to try it and share? Please tell me in the chat. 0 minus 2. In the chat, excuse me, is Anaya. High five, dude. Negative 2. So we began with our parent graph. That point was 0, 7. We did a translation of negative 2 to the x, to the horizontal. We ended with negative 2, 7. This is our answer. So in Edmentum, maybe I should have just cut and pasted so you guys would see what it looks like. You're going to type in the parentheses. So you'll have to do that on your keyboard, I think. Do shift and then 9 probably to get a parentheses. Type in your new x and your new y in Edmentum. I'll hold on this screen if anyone's writing. And I want to do a couple more examples with you guys, and then we'll stop, and each of us will do the mastery test for today. We're just using the rules from last week applied to single points. Things will be a little trickier when we get to the warping ones, where we have to actually multiply a number. So we're going to do those too. Let's start with just translating it first. Here we go. New one. Assume negative 8, negative 5 is on the graph of f of x. So this is our original or our parent point, okay? Same thing. It's on the original. Find the corresponding point for the function f of x minus 1.
Hi, Josiah.
Hey.
I got kicked out.
Sorry about that. I'm glad you came back. So we start with the original point. You can think of this as like the original whole graph, right? But it's not even telling us what f of x is. We don't know what kind of shape this is, but it doesn't really matter because we know that this point, negative 8, negative 5, is on it. Then we're going to do a translation. And what's the translation? It's f of x minus 1. What does that mean? It's in the parentheses, so we do the opposite to just the x. To just x. Leave y alone here because it's not a vertical translation, right? It's just a horizontal. What's the opposite of minus 1? We're going to do plus 1 to just x. So what's our new result? Negative 8 plus 1. That's our x number. Our y stays the same at negative 5. Take a minute and practice this. What do we get when you combine negative 8 and a positive 1 together? What's our result? If you feel willing to try it and share, I'd love to hear your answer in the chat. See it in the chat.
It would be negative 9.
Levi, right idea.
Oh, negative 7. Sorry.
Good. No, it's okay. Don't be sorry. Thank you so much for trying it and for jumping in. In the chat, let me just see who's trying it. Tatiana and Tira. High five, you three. So good save on that, changing your mind. Now, why is it not like going to be deeper in the negatives in negative 9? Because this 1 is positive. So the 8 and the 1 are
positive number. Oh.
Go ahead, Levi. My bad.
I was saying because it's a positive number.
Exactly. And I think of it as like they're opposing forces. They're like, the negatives are trying to or win the world over to be all negative. The positives are trying to make the world all positive. These guys are fighting each other. And that means the answer, after we combine them and collide them, it's going to be something in between 1 and 8. 7. If 1 was negative also, then they would stack up and be negative 9. And notice that the negative 5 is still negative 5 because whatever f of x looks like, we know the whole thing just shifted plus 1. So maybe we had one of these. Who knows what the f of x actually looks like here? Maybe it's this, and then the whole thing just went over 1 for the translation. So this first point was at negative 8, negative 5. And then we shifted it, and the new one is negative 7, negative 5. That's what's happening here. We don't have to worry about the whole function, but here's an image of what that might look like after doing its plus 1 shift. Now, just a reminder, all we're asked to do for this mastery test is type in the resulting coordinate. Excuse me. And be careful. It doesn't give you the parentheses button, I don't think. So you'll have to type that parentheses and then your X number and then your comma and Y number. You'll see it when you try it. Just pay attention to that. Be aware. All right, let's do another one. I'm going to skip to this one here. So assume 5 comma 4 is on our original graph of f of x. Parent graph. Find the corresponding point when the function for the function f of x plus 4. It's outside. That means it's vertical this time. And we do it at face value, no opposites here. So because it's vertical, we're going to leave x alone. So 5 comma 4, translate. We're going to do it to just y. What are we going to do to just y? We're going to do plus 4 to just y. X stays the same, leave x alone. Stays the same. So that turns into 5 comma what? We're leaving our x alone. Okay, there's a couple messages in the chat. Our rule's telling us plus 4. That's the coming from here, our rule. And then you're going to apply that to just the y number. So if I'm starting with a 4, we're adding 4 more. What did you guys get? Nice job, guys. Tira and Tatiana and Anaya. The rule was plus 4. I didn't mean to make this a trick question. We started with a 4 here, and then we had to add 4 from there, and resulting in 8. So that's where that 8 is coming from. Oops. No, do not be sorry. Thank you for answering. All of you who are answering and trying it, verbally or written, I'm going to put that stamp on your guys' sheet, which if you did look, I apologize. I haven't updated it over the weekend, but I plan to today. So I appreciate you guys trying. That's participation. If we had a picture of this, which we don't, and we don't need to concern ourselves with it, we have our original. Maybe it's a straight line. They're telling us 5 4s on the original. Then we do the translation, f of x plus 4. So our new one is the same looking as the old one. Shape is the same. It's just been pushed up 4 units at a 5 comma 8 this time. That's our plus 4 in the middle. So think about it that way. Okay, no questions. Let's Actually, I'm going to kind of skip. Let's do some of the multiplying ones now, because I think these are the trickier ones. Okay. Now the rules are the same as last week. Keep that in mind. Things are a little different though when we're doing multiplying. Uh-oh, I've lost someone again. So assume we have -6, -5 on our parent graph f of x. This is our original. Find the corresponding point for the function f of 3/4 x. This is our rule. This is our transformation. It's in the parentheses. You know what that means. It means we're going to apply it to just x. Why? Because that's horizontal. X is horizontal, y is vertical. Apply to just x. Y gets left alone. And we do the opposite when it's in the parentheses. Okay? Anytime it's in the parentheses, opposite. Now, we did this last week. We don't, for our multiplying, our opposite isn't going to be like plus minus. It's going to be the reciprocal. So how does this look? Our original point is -6, -5. Our translation this time, the opposite of 3/4, the reciprocal of 3/4, remember that? We flip the fraction. So we're going to times 4/3 to just x. Y stays the same. Y is left alone. So now we've got to do a multiplying like we did in our warm-up. Now y is left alone, so I know that's going to be a -5 again. But what goes in the x location? It's going to be -6 times 4/3. So we got to practice these. Couple things to keep in mind. Negative times a positive, our answer is going to be negative. Remember that. Go ahead. Yeah, go ahead, Tira.
So for the fractions, are we always going to switch them? Like switch the numbers?
When it's in the parentheses, we always switch it.
Okay.
If it's out of the parentheses, we keep it the same. We do it at face value, and we apply it to y. In the parentheses, it only gets timed to x, only x. And it's going to be flipped. I see some more chats. Hang on. Oh, Anaya and Savannah. And I think that was from last time. Good job, both of you. Thank you. And Tiara for asking. Yeah, so we're always going to flip it when it's in the parentheses, folks. Always flip it in the parentheses. Just like how we always made it negative or positive, we changed its sign when it was in the parentheses too. Okay, so here's negative. And then 6 times 4 on top, 3's in the bottom. I'm going to do it the second way I showed you guys. So 6 divided by 3, what's 6 divided by 3? That's just straight up 2, right? So -2 times 4, resulting in -8. So our new point is at -8, -5.
Josiah?
Please.
So to get a solid number, would we have to do 6 divided by 3?
No, good question. Let's see what happens if we did it the other way. Let me just change my color to compare the two ways. Okay, so going back to here in purple, let's say we didn't do the 6 divided by 3 and we said, forget that. I don't want to do what he's saying. I want to try it this way. Multiply the top two numbers. So 6 times 4 is 24. Still, we have our 3 in the bottom. Don't forget. Do the division, 24 divided by 3. Don't believe me, check it in your calculator. -8. So you have options. I'm happy with you doing it either way. I just want you to be armed with both ways to do it, should you choose to use either one. Great question, and thank you for asking. Awesome. Good job, guys. Okay, so and I like also that Tira pointed out for us, and brought it to my attention again. We flip the fraction when it's in the parentheses. We don't flip it if it's outside. because if it's outside, it's a vertical rule, and we do them at face value. If it's inside, it's a horizontal rule, and we flip it or we make it positive negative if it's a plus or minus 1. See what's next. Okay, if we look at this question, assume 6, 1 is on the graph of f of x. Find the corresponding point for the function f of 3x. Okay, guys, gals, folks, 3 is the 3 times x, that's in the parentheses. What does that tell you? It means do the flipping because it's in the parentheses. So we're going to flip the fraction, making it 1 over 3 that we multiply. It's not a fraction to start, is it? It's a 3. But I always want you thinking, flip it and switch the numbers like Tira said when it's in the parentheses. Flip the fraction, switch the numbers. Does it apply to x and y? No, it only applies to the x. Y, leave it alone, it stays the same. So let's see how to do this. I also have a note there. I didn't read it last time, did I? Important, to do a horizontal stretch or shrink, multiply the x values by the reciprocal and keep y values the same. So again, our original is 6, 1. We do our translation. We talked about that. It's going to be times 3 or times 1 over 3. We want to flip it because it's in the parentheses. So times 1 over 3 to just x. Leave y alone. Leave y the same. So my y stays the same. Cool. So it's going to be 1 again. Here, though, we've got 6 times 1 over 3. I should have changed different numbers. If we try this out, we've got 6 times 1 on top. Well, that's still 6. 6 divided by 3, 2. So there's our ending point, or our transform point. Okay, now what if it's not inside the parentheses? What if we get one where it's timesing on the outside? Here we go. So now our starting original point is negative 9, 6. We're going to do some translation or transformation. What is it? It's negative 1/2 times f of x. It's outside. It only applies to y now. X is going to be left alone and stays. Our transformation applies to y, and we don't flip it. We do it at face value. So here's our transformation. That means we're going to times, multiply, negative 1/2 to the y number. We're going to leave x alone or keep it the same. Cool. So negative 9 is going to stay because this is transforming the y's, not the x's. So 6, I'm sorry about the same numbers over and over. I didn't realize that I did that. 6 times 1 on top, divide by 2, negative 3. So original on the left here, we do our translate or transformation by multiplying it, and then we have our ending or our transformed version on the right. And it's kind of cool, no matter what f of x looks like, because it doesn't tell us, right? We don't know if this is a parabola or the cubic or the straight line or what, or some other weird funky function that they made up. We don't know what the original looks like, but we just know that this original point would transform to a -9, -3 after doing that exact transformation that they gave us. All right, and I've done it again. I've used up our whole class time. I'm going to do the same thing now that we were doing last week, which is I've got a couple extra examples to do. So I would like to have you guys, if you're feeling comfortable with this topic today and this same procedure that I've been doing with you, go ahead and start your mastery test. If you'd like to just see more examples for your notes, I'm going to do 2 more examples. And then any questions, if you want to go over any of the previous ones or the new ones, you tell me now or anytime. I want your questions as well.
And the mastery test is going to be function values, right?
Correct. Yeah, it's called functional values. Good.
Okay.
Totally. So go ahead and start it if you like. I will really quick take a roll. Let's see, Savannah, Victor, Levi. No film on. Tira, Anaya, Brooke. Anthony, are you here? Anthony! High five, dude. Anthony's here. And Tatiana and Xavier, you are here too. Very good. All right. All right, let's check this one out. Hopefully you guys are trying this one on your own. We have our given starting point, 1, 9. And we're supposed to do this transformation 2/3 times f of x. So our original is 1, 9. Okay, this time I'm going to ask for any volunteers who are willing to try it and just tell me in the chat or out loud verbally, what are we going to do? What is our move here? What are we going to multiply to what? Can we tell from our translation rule above? Is it going to multiply to the x or to the y? And is it going to be flipped or is it going to be 2/3? Any ideas? In the chat, I see something. Beautiful. Tira and Anaya multiply to the y in its face value. Tira and Anaya, high five. Boom. We multiply this number, the 2/3, to the y. Its face value. And it's to the y because it's outside. So inside or outside the parentheses is telling us basically everything. Is it to the x or y? And it's telling us flipped or original, flipped or face value. So I'm going to write that here. We're going to multiply 2/3 to y because it's outside. That's telling us. So 1 stays the same, or x stays the same. And now we got to do the actual math. So 9 times 2/3. Okay, practice this along with me. 9 times 2 on top. Divide that number by 3. For a total of 6. If we want to do it by reducing as we go, then we would have 9 times 2 over 3. 9 divided by 3 is 3. 3 times 2 is 6. Okay, I'm just going to mark down folks who tried answering a question today. High five to you guys. Thank you. Participation. I have another example, and I'll do that one with you. Okay. Try it along with me. Assume that 1, -8 is on the graph of f of x. This is on our original function. Find the corresponding point for the function f of x minus 4. Oops, 1, -8. There we go. Our translation or transformation this time, it's outside. So that means we do it at face value and we apply it only to y. Apply to the y number, leave x alone. So x is left alone, so it's still a 1 here. 1, -8, still 1 comma something. -8, and at face value, that's going to be -8 minus 4. Okay, here we have, we're adding and subtracting, right? And they're both negative. So -8, and we're smashing that together with -4. Because they're the same sign, they're going to stack up in the negative direction. Here's -8, and here's -4. Well, there's nothing to cancel, right? When they run towards each other in battle, there's no canceling. So they're all just going to stack up as negatives for a total of -8, or no, -12. You can just count up those minus signs. Should be 12. So you guys do your best today. Do your mastery test. Tomorrow is Tuesday, so tomorrow's my extra day in the afternoon with you guys. So if you have any questions, or if you're feeling like you'd like to go over this with me in a more one-on-one environment, then please join me tomorrow afternoon on Tuesday at 3 o'clock. Not today, tomorrow. Today I've got